Hey guys, welcome to types of crystal solids. So crystalline solids, let's talk about the types, right? And so when we talk about, look at the periodic table, what do we have? Well, we have atoms. We have atoms, right? We have atoms, and then atoms can combine into either molecules or they can make ionic compounds. So those are the three types of solids we can have, or we're going to have. All right? And so when we talk about atomic solids, there's going to be three of them. There's going to be metals, metallic solids, there's going to be non-bonding atoms, and there's going to be what we're going to call covalent networks. All right? And so these are the three we're going to have, and that's horrible writing, I'm sorry. All right, so we got atoms that can be metallic, right? All right, so metallic, let's talk about metals, all right? Metals first, right? What holds them together? Metallic bonds, right? Metallic bonds. Now, in this course, we don't really go through metallic bonds much, right? But there are bonds, and they do make bonds, okay? And how the electrons work is kind of a delocalization. Let's try this again. Delocalization of the electron. All right. And, you get into higher level courses, you'll dive into that if you do. Now, metals, some of their properties, right? They have variable melting points. Okay, that some of them have very low melting point, right? Like gallium melts in your hand. Mercury's already a liquid at room temperature, so at 25 degrees Celsius, right? You can see the melting points. In fact, a great resource, the website, the P table for the periodic table, it shows you the state of everything at 25 degrees Celsius, and you can change the temperature and see all their melting points when they become a liquid and then if they vaporize. So some metals have very, very low melting points. Some have pretty high melting points. All right. Most of them are malleable. And what does that mean? That means we can hammer it into sheets. All right. They're ductile, which means it can be drawn into wires. And they're typically conductors. All right. Heat, electricity. So those, right, are metallic ones, solids, and we are not going to go into those mostly. We're going to go into the atomic non-bonding ones, all right, and these are held together by intermolecular forces, right? Intermolecular forces hold these together, right? They are not bonding, and they usually have low melting points. All right. An example of this would be like xenon, solid xenon. All right, solid iodine. They're usually brittle. Right, so they cannot be hammered into sheets. The opposite. All right, they would shatter, and they're typically non-conductors. Then we have covalent networks. And these are actually held together by covalent bonds. All right. They usually have high melting points. Think diamond, quartz, those types of things. They're usually hard, and they're usually semiconductors. which sometimes they conduct, sometimes they don't conduct. All right, it depends on the situation. If we look at the molecules, the molecular compounds, all right, they are held together by intermolecular forces. Like ice is held together by intermolecular forces. Okay? They typically have, right, they're made out of molecules. Right? They typically have low melting points. Right? They're typically brittle and non-conductors. All right? So you think about ice is a great example, but there's other ones you could use. But all right, it's brittle. It doesn't conduct heat. It doesn't conduct electricity. All right, but it does have a low melting point. But that's ice is held together by intermolecular forces. They can't make any more bonds. Then we have ionic compounds. And ionic compounds, right? These are made out of ions. Ions, all right? They're the ones that, charges hold them together. All right, we're going to put Coulombic forces down. All right, and they typically have high melting points. For example, NaCl, I have 801 for one source. 801 degrees Celsius is its melting point. Right? They're brittle and hard, but they are conductors. All right? So those are our types of crystalline solids. So we talked about the three crystal structures we'll talk about, which was simple cubic, face-centered cubic, and body-centered cubic. And then these are the types of solids. All right. So if you have any questions, reach out. Otherwise, we'll see you next time. Take care.